Hello everyone. Today we will solve one question from structural analysis. So the given question is a frame is given. So what is the rotation of the member at joint C for the frame shown in figure? So the figure dimensions are given. This is the length of both the members L, that is equal to 5 meter, and EI is both these members are having uniform cross section and material properties. So EI is given, that is in kilonewton meter square, that is a unit of EI. So we have to find what is the rotation at joint C. So options are given like this. So let us solve it. So we can see that in this frame, loading is like this. We have a concentrated moment at the joint B. So first let us understand how it is going to deform, how the deformed shape will look. So if we apply a clockwise moment at the joint B, so what will happen? So this beam will deflect like this. It will have a clockwise rotation at joint B and it will have anti-clockwise rotation at joint C. This will be your clockwise rotation at joint B. And also because of this loading, your column also will deform something like this. So we'll have some rotation at joint A also, because the joint A and C are not fixed, it is a pin joint, so will be having some rotation at the joint A and C. So this is a rigid joint B, so that is why this angle will be maintained as 90 degrees. That is why it will take a deflected shape, will be something like this. So our question is, we have to find out what is the rotation at joint C in radian. So the unit is radian because all options are given in radian. That is why this is specified. EI is in kilonewton meter square. So you have to get the rotation at the joint C in radian. That means all the quantities, the moment you have to substitute in kilonewton meter. So all the quantities you have to substitute in kilonewton and meter, so that you will be getting final value for rotation is in radian. Okay, let us solve it. So we can solve this question by using different methods. You can use the slope diffraction method or you can use any other method. But easy method to solve this question without spending much time, that is the moment distribution method. From the given data, we can see that this member BA and BC both are having same length and same A value. That means your stiffness of BA and BC will be equal. So if the stiffness of member BA and BC are equal, then you can directly say that your distribution factor for both these members BA and BC will be same. Because stiffness is same, your distribution factor must be same, because the far end condition also same. If the distribution factor for BA and BC are same, then you can say that the distribution factor for BA and BC will be equal to 1 by 2. Because at the joint B I have two members, sum of the distribution factors of all the members meeting at any joint, that sum should be 1. Both these members are having same distribution factor because both are having same stiffness. That is why your distribution factor for BA and BC will be equal to 1 by 2. That is how we can calculate the distribution factor for the members BA and BC without doing any calculation. But I will write how to get this value, we will derive. So you can find out the stiffness of member BA, that is my far end is Sibley support or pinned, so this for the stiffness will be 3 times EI by L, so that we can write 3 EI by L is given 5. And similarly your distribution factor for BC, that is also 3 times EI by L, so that is also 3 times EI by 5. So now I can find distribution factor for BA, which is equal to KBA by KBA plus KBC. So KBA and KBC both are equal, so you will be getting 1 by 2. Same will be for distribution factor for BC. So your distribution factor for BA and BC, that is equal to 1 by 2. But I will tell you, you should not do this calculation in your exam. because it will take you some of your time. So before going for any sort of calculation, you just observe the given question and think about for some time whether should I go for any calculation or not. Here you don't need to go for any calculation. That is why the question is framed like this. The length are same, far and boundary condition is same, A value is uniform, so that you should be able to eliminate this step. So once you see this question, directly you should be able to write the distribution factor for BA and BC are equal, and if that is equal, it will be equal to 1 by 2. That is from this condition. The summation of your distribution factor at any joint, it should be 1. Meeting at any joint, the distribution factor sum should be equal to 1. Because I have only two members, so we can write 1 by 2 will be the value of distribution factor. So now we have two members and I am applying a moment, let us say M. So I am applying a moment M at this joint. So what will be the moment shared in the member BC and BA? So the moment MBC, so that will be equal to distribution factor of BC times the moment. So if you apply M moment, distribution factor for BC times M will be shared in this span BC. So distribution factor for BC, that is equal to 1 by 2, that means M by 2. So in this case M is 12 kilonewton meter, so this will be 6 kilonewton meter. So similarly your MBA, that is a moment shared in this member BA or in this column BA, that is distribution factor of BA times your M. So that is also your 1 by 2 into M, that is M by 2, that is also 6 kilonewton meter. This one also you can write directly because I am applying total moment is 12 and both these members are having distribution factor is 1 by 2, 1 by 2. That means 12 out of this 12 kilonewton meter, the 6 kilonewton meter will be shared in the span BC and remaining will be carried by member BA at this joint B. So now your problem will be reduced to a simple beam type question. You can take this span BC separately, and what is the value of MBC? That is this much kilonewton meter clockwise. Okay, so this here you can take the moment is 6 kilonewton meter. Let us take this is M dash. Okay, let us take this span is L. Okay, so now our question from this frame, it has reduced to a B problem. You can take it as simply supported B. So no matter this, you can take it simply supported B. You just apply the moment MBC. Okay, so this will deflect like this. So you just find out the value of rotation theta C in this beam. That will be your answer, which is asked in the question. So this is a very well-known result. So we have a simply supported beam and we have moment M, and let us take the span is L. So it will deflect like this. We will have some angle theta at this joint. So that theta will be ML by 6 EI. So your answer will be theta C, that is equal to, in this case, M dash L by 6 EI. That is, what is the value M dash? That is 6 into 5. L is equal to 5 meter by 6 EI. So which is equal to 5 times EI. So what will be the unit? Radian. Because I am substituting EI is in kilonewton meter square and length I am keeping in meter and your moment we are keeping in kilonewton meter. So that is why your answer will be in radian. The answer will be 5 by EI radian. So this will be your final answer. So that is option D. Now if anybody have doubt how to get this, it is a standard result. Even though if you forget this result, you can derive it within second. So let us see how to derive it. So you take the simply supported beam. We have a moment, concentrated moment at one end. So we can use here conjugate beam method. Draw the moment diagram for this loading. So this is your M diagram and this is my M by A diagram. And if you are using the conjugate beam method, you will take the loading as M by EI. Support condition will remain simply support in this case. And we have to find the rotation at this joint. How to derive equation for slope or rotation in the conjugate beam method? You take the corresponding conjugate beam, the reaction at this joint, that will be your rotation in the real structure. So this reaction you can easily find out. If you have a triangular load, this reaction will be 1 by 3 times your total load in the beam. So what is the total load? So what is the total load? We have M by A this value and this is your length. The total load will be area of this triangle, that is half into ml by EI. So we can substitute here half into ml by EI, that is 1 by 3 ml by 2EI, that is your ml by 6EI. So this is how you can derive, even though you forget, but after deriving 1 or 2 times you will be automatically remembering this value. This rotation will be ml by 6EI and this rotation will be just double ml by 3EI. That is how you have to remember it. So we have discussed some of the related theory part also in this question, but to solve this question you will take less than 1 minute.